There exists a fundamental aspect of reality that allows everything to be in relation. In this model, that aspect is what we call gravity. We do not fully define it yet, but its effects are sufficient to describe how reality behaves. This forces a different interpretation of the quantum domain, black holes, the cosmic cycle, and spacetime itself. Reality is not only a surface, it reveals itself through layers of organization. In this first video, we'll define the framework, gravitational strings and four coexisting properties, and how they redefine gravity across scales and reality itself. This touches on the quantum domain, the role of infinity, and initial implications for extreme regimes like black holes. In the next video, we'll show how gravity operates within the cosmic cycle. This model is evolving continuously. It is presented as a working stage of an ongoing investigation. During the development and editing of this video, new hypotheses emerge that refine parts of what you're about to hear. This reflects the model at this stage. As we progress, they will be explored in future videos. What follows is a snapshot of a structure that continues to be refined as new internal connections become clear. For a long time, we learned to treat gravity as a force, then as the curvature of spacetime, more recently as something that might emerge from deeper structures. These approaches work, but they work within clear limits. When we try to cross scales from the quantum to the cosmological, something stops fitting. When we try to understand non-locality, uncertainty, extreme collapses, or the very structure of spacetime itself, our descriptions become insufficient. The problem is not in the equations. Equations are expressions within a mathematical language, but language depends on how we interpret reality itself. And that reality depends on how we organize the idea of gravity. Equations are not the origin of the problem, they inherit it. When interpretation shifts, the equations must shift with it. This work was developed with the assistance of AI as a tool, organizing ideas and pointing inconsistencies, including those that emerged from the interaction itself and had to be actively corrected. Conceptual similarities with existing theories we had no prior knowledge of were treated only as external references, not as foundations. The framework was built independently from them, and these ideas may carry a degree of coherency precisely because they were formed outside the internal constraints of established physical paradigms. They were not shaped in dialogue with authority, but with the problem itself. This search did not arise from abstract speculation. It began when ready-made answers proved insufficient and ultimately untenable in the face of concrete events of existence. I had to know, what is our essence? What is the essence of everything? And what happens to it? I was looking for coherence, a foundation capable of describing the condition under which existence becomes physically manifest and under which manifestation fails. That path led us to string theory, but it wasn't enough. If all matter is made of strings, what are they really? How do they emerge? Is that the final level? How can they exist at all? String theory gave us a language, but it didn't give us an answer. So we kept asking and we kept thinking. If, at the most fundamental level, everything is strings, what happens to them at the deepest core? And where would that be? Where do they go? If they persist, if they do not simply vanish, then something must act on them. That's when black holes enter the picture. And this is where the problem becomes unavoidable. We thought to ourselves, if there is something as fundamental as strings, and if something could have an effect on them, it should exist somewhere in the cosmos. And in the cosmos, there is nothing more efficient at acting on something, what is described as the bending of spacetime, attracting anything, even light, than a black hole. So we began thinking about black holes as gravitational entities with a specific and unique role in the cosmic cycle. Their mystery took on a different meaning. It was now what made them fundamental. And that is how we arrived at gravity, the cosmic cycle, and everything in between. What is being presented here is an attempt to structure all of that. This video presents hypotheses built over years of insisting on the same questions. We started from the essence of the problem. This is a framework that operates before conventional physics, at the level where those concepts are defined. We reinterpreted the problems, and by doing so, we reorganized the questions and the possible answers. And the central answer and established hypothesis is simple to state, though profound in its implications. Here, gravity is understood as a string, a distinct kind, endowed with specific properties. These properties are consistent with phenomena already observed by physics, for example, orbits, trajectories, the speed of light, black holes, quantum tunneling, entanglement, uncertainty, and the theoretical limit of description, what we call singularity. Before we go any further, one essential clarification remains. What is presented here is not a closed system, is not a finished theory. It is a framework under construction. And as these ideas developed, as the hypothesis deepened, it became clear that it was time to share them. In an age where information can reach anyone, anywhere, sharing a framework is sufficient. It is information. It may be useful, incomplete, or irrelevant. That judgment belongs to whoever engages with it. With all that being said, let's enter the first notions of the four properties. In this model, gravitational properties are never isolated in reality. They do not exist independently, nor can they be meaningfully separated in nature. They always act together, simultaneously, across all scales. Their individual description is a didactic choice, not an ontological one. It serves only to make the structure intelligible to the human mind. Any apparent prioritization of one property over another reflects the configuration of a specific quantum state, not the suspension, absence, or dominance of the remaining properties. With this in mind, we arrive at the core claim: gravitational strings. Gravitational strings are fundamental non-vibrating structures that underlie physical manifestation and govern the conditions under which vibrational states may emerge. Gravitational strings do not vibrate like ordinary physical strings. Among other capacities, they govern the conditions under which vibration may occur. Vibration and physical manifestation only emerge when a specific configuration of gravitational properties allows a normal string to enter a vibrational state. Normal strings may be understood as localized expressions emerging within the gravitational structure, a point we will explore later. If absolutely everything emanates gravity even minimally, imperceptibly to our instruments, especially at the quantum level, then between any structures, a particle, an atom, a molecule, you, a building, a star, there exists continuous gravitational connectivity. This is a connective reality, what we call the extended regime. Extension refers to the non-local and intrinsically non-finite spread of gravitational strings. Connectivity is the structural inseparability that emerges from this extension. In this regime, gravitational strings form a diffuse, intermingled structure, not through discrete links, but through continuous structural overlap. Connectivity is the structural consequence of extension. It does not imply fixed connection points or a connecting agent. Connected does not mean identical, it means non-separable at the structural level. It describes a condition in which separation loses clear physical meaning. Where there is no vibration, physical manifestation is not possible, but gravitational configuration remains. Before vibration, there is no thing. There is only configuration. Gravitational configuration does not arise from a single property. It emerges from the simultaneous and inseparable action of all gravitational properties. Before continuing, it is necessary to address infinity and the tendency toward infinity within this model. Here, infinity is treated as a structural feature of nature. What evolves through physical processes is not infinity itself, but a continuous tendency toward infinity, a directional behavior through which configurations transform without ever reaching closure. This tendency does not belong to a single property, it belongs to all of them. Because gravitational strings are structurally extended and non-finite, their configurations continuously overlap, producing a connective reality that never reaches a final state. What becomes finite are not the structures themselves, but their local manifestations, temporary expressions that emerge as observable events. In this sense, observable reality consists of localized manifestations arising from an underlying structure that remains connective, overlapping, and permanently open. What changes is never the existence of gravitational properties, but the quantum configuration through which they become expressed. By quantum configuration, we mean the specific way gravitational properties are organized at a given state, allowing a particular vibrational pattern, and therefore a physical event to emerge. In this sense, what we call a normal string is not independent from the gravitational structure. Normal strings may be finite in local manifestation, yet they contain infinitely possible vibrational states. It is a finite section, a local manifestation, emerging from an infinite background. Within this model, infinite vibrational possibilities give rise to infinitely possible manifestations, all emerging from finite local expressions of normal strings. It is the tendency toward infinity of gravitational properties that continuously transforms the state of the system, allowing different expressions of gravitational organization to emerge across scales. In such continuous overlap, gravitational effects are not isolated events nor independent exchanges. They arise through continuity, an inseparable underlying gravitational structure in which interaction and configuration coexist. This structural overlap is what we refer to as the quantum domain. What is described here are overlapping quantum states, a regime in which time and measurable structure emerge only when quantum configurations give rise to vibration. It consists of gravitational strings permeating everything, matter, space, scales, and all observable manifestations. It underlies all scales. What we call microscopic and macroscopic are expressions within the underlying quantum domain. Gravitational organization generates observable manifestation through specific quantum configurations, while the underlying structure remains present. This is not a deeper layer reached by descending scales. It is the structure in which all scales are embedded. In this sense, everything remains intrinsically connected, overlapping, intertwined. And within that relation, gravity's properties authorize the vibrational state of normal strings and everything that follows. Particles, molecules, tissues, organisms, living beings, the sun, the earth, the moon, and all observable interactions extending toward infinity. No property acts in isolation. Extension, regency, tension, and compression exist inseparably. In the quantum domain, without the inseparable action of regency, tension, compression, and extension, there is no vibration. Without vibration, there is no particle. Without particles, there is no observable physical reality. And without particles and vibration, spacetime itself does not exist. Matter and spacetime, therefore, are not fundamental. They are transient physical expressions of quantum states guided by gravitational strings and their properties, working within a connective structural relation that precedes manifestation. Without vibration, there is no spacetime. Spacetime is not fundamental. It appears only when vibration becomes physically possible. This implies that if gravitational strings define the conditions for manifestation, then their behavior must be structured. The four properties. To organize these ideas, we propose that gravity always manifests through four coexisting properties. It is not a question of being gravitational by name. The designation is secondary. What matters are the structural properties attributed to this specific type of string: extension, tension, compression, and regency. These properties enable overlapping quantum configurations. They do not act independently, nor can they be meaningfully separated in nature. What we observe reflects the configuration of the quantum state, not the dominance of a single property. What changes is not an isolated property, but the global quantum state of the system. That state determines which gravitational effects become sufficiently expressed to produce observable events within a given regime. As stated earlier, infinity here is a feature of nature, allowing a structural tendency through which configurations transform without closure. All gravitational properties participate in this tendency simultaneously. There are no stable systems. Stability is always local, provisional, and apparent. Because all gravitational properties tend toward infinity together, no quantum state and therefore no physical manifestation can ever be final or closed. With this in mind, we can now describe how gravity expresses itself through distinct coexisting properties: tension, compression, extension, and regency. Tension. Tension is observed macroscopically in trajectories, orbits, and regular motions. It allows predictability to emerge locally, not because the system is fundamentally stable, but because a specific configuration of gravitational properties permits what we call regularity. This regularity is not an intrinsic feature of reality, it is the externalized expression of a specific quantum configuration. In this sense, classical physics functions effectively in this regime not because it captures the essence of gravity, but because it describes a limited domain in which tension becomes sufficiently expressed to produce predictable outcomes. Tension, therefore, is not restricted to the macroscopic world. It is present across all scales, from the quantum domain to the macroscopic extremes observed in black holes. In black holes, for instance, tension reaches an extreme expression, acting within configurations that continuously direct gravitational interaction inward, pulling everything toward the core. Tension enables temporary organization, that is, vibrational manifestation, as long as the quantum configuration of the system allows it. All such organization is inherently transient, since no configuration remains fixed, even at the largest observable scales, which themselves exist within the quantum domain. What we perceive as regular motion, equilibrium, or persistence is not a stable foundation, but a transient condition authorized by tension acting together with the other gravitational properties. But this is only one mode of expression. Compression. Compression carries particular relevance because it is in this regime that some of the most extreme and observable gravitational phenomena emerge, where gravitational interaction reaches its highest known intensity, such as in neutron stars and black holes. Compression drives configurations toward increasingly compact states. As density increases, compression expresses itself through uniform compaction, acting together with all other gravitational properties. Tension, compression, extension, and regency do not act independently. They are concurrent expressions of a single gravitational process, each becoming observable according to the system's quantum configuration. What we describe as compression is not a separate action, but a mode through which gravitational properties manifest under specific conditions. These are not sequential processes. They are simultaneous expressions of the same extended gravitational structure. As systems evolve toward higher density, compression becomes increasingly evident in stellar remnants and black holes, accounting for gravitational collapse and the progressive limitation of observable physical manifestation. If the event horizon is taken as an observable boundary associated with extreme gravitational organization, then gravitational interaction must be understood as acting across that boundary, with tension directing configurations inward, compression driving increasing compactness, and regency associated with the limiting organization of vibration at the threshold of observability. Under extreme conditions such as those present in black holes, tension contributes to the inward direction of configurations, acting as part of the same process that leads matter toward the core. Beyond the event horizon, compression becomes the most evident observable expression, while all other properties remain inseparably present within the same extended configuration. Compression acts as systems approach extreme density, what is conventionally described as a singularity, with all gravitational properties tending toward infinity. As this limit is approached, vibrational states tend toward zero. At this limit, no single gravitational property retains independent descriptive meaning. All properties converge beyond distinct characterization. Without vibration, there is no spacetime, no metric applies. No classical physical description remains valid. Singularity in this sense refers to a regime beyond metric description, where conventional distinctions between beginning and end lose meaning. At extreme compression, differentiation vanishes, and previously distinct configurations become indistinguishable. What disappears is not existence, but distinction. This does not imply loss, but reconfiguration within an underlying extended gravitational structure that never becomes fully separable. There are theoretical predictions and observational indications that gravitational phenomena may leave persistent effects in the structure through which they propagate. This effect should not be understood as memory in time, but as reconfiguration within the underlying gravitational structure itself. In this sense, what is preserved is not information as stored data, but a transformation of structural relations. The system does not return to a previous state, but to a reconfigured condition that still carries traces of prior configurations. It contains in its extended and overlapping structure the full set of possible configurations, as if the universe were expressed as a continuous score, not as stored information, but as structural possibility. And this behavior cannot be understood without considering its reach. With that said, compression is the regime where testability may become physically accessible. Possible approaches to explore this will be addressed in future work. Extension. Extension is a fundamental property of gravity. It refers to the non-local, non-finite, and continuous spread of gravitational strings. From extension, connectivity emerges as a structural consequence. Connectivity is not a separate property but the natural result of an extended structure that does not admit true separation. Gravitational strings being extended form a continuous and overlapping structure that permeates all existence. This interconnected structure is what we refer to as the quantum domain. What we observe as particles, matter, and spacetime are localized and transient configurations arising within this extended structure. The term transient here does not refer to human notions of spacetime. In this regime, classical notions do not apply. There is no fixed localization, no classical causality, no permanent structure, no stable notion of spacetime. Physical manifestation is not independent from this underlying structure. It is a temporary expression within it. Everything that becomes observable emerges within this structure. Everything that ceases as observable dissolves back into it. But emergence does not yet account for how manifestation is organized. Regency. Think of regency as the organizing aspect of gravitational configuration, the aspect that, together with tension, compression, and extension, allows vibration to stabilize long enough to appear as a particle, and with it, localization and spacetime. In practical terms, regency circumscribes a finite section within an extended gravitational string, organizing the conditions under which a normal string can sustain vibration. It is not a separate agent, but an inherent property of gravitational structure itself. Regency is present across all scales and regimes, quantum, macroscopic, and extreme, always inseparable from the other gravitational properties. These configurations emerge through changes in scale and regime that never reach a final state. They are intrinsically transitory, arising from a connected structure tending toward infinity. In the quantum domain, when regency becomes sufficiently expressed, localization and spacetime emerge together as aspects of the same event. This does not refer to duration in the classical sense. What defines regency is not time but configuration. A regency condition may exist only long enough for a particle to appear and dissolve, or persist across macroscopic scales, as in planets, stars, or black holes, as long as the underlying configuration sustains it. When the necessary conditions are met, regency enables vibration to organize into particles, structures, and observable physical form. When they are not, localization does not occur, and no stable manifestation emerges. In the quantum domain, this gives rise to phenomena such as non-locality, tunneling, and uncertainty, not as breakdowns of order, but as natural expressions of a continuously connected structure. Regency is equally present in microscopic reality. It is what allows gravitational organization to sustain form and permit persistent physical manifestation. In extreme regimes, regency remains present as part of the same inseparable process in which all gravitational properties act together under conditions tending toward infinity. We propose that one of its observable expressions under such conditions is associated with the event horizon of a black hole, the last region where localized organization remains observable before conventional physical description dissolves. This should not be understood as a boundary in isolation, but as part of a continuous configuration emerging from overlapping quantum states across scales. Because all gravitational properties tend toward infinity together, regency cannot be treated as superior or foundational in isolation. It varies relationally, always as part of the whole. When all properties act together, what emerges is what we recognize as reality. The quantum domain is the foundation regime in which everything occurs. It is not a place but the underlying condition of existence itself. Physical manifestation does not exist independently from it, it emerges within it, as a localized expression of a broader connected structure. What we call matter, spacetime, and observable reality are transient configurations arising from the organization of gravitational properties. We are one of those configurations. All gravitational properties vary together relationally as part of a continuous and overlapping process that never reaches a final state. What we observe is not reality in its entirety. but a localized manifestation within an extended and connected whole. In this framework, quantum states are not isolated events. They are points of expression within an overlapping structure that exists beyond classical notions of time. What appears as sequence, causality, or linear progression is the surface interpretation of a deeper, nonlinear configuration. And although these manifestations are transient, the process is not without persistence. Every configuration leaves traces within the structure from which it emerges, not as stored information in time, but as modifications in the relational state of the system. Nothing is lost, configurations transform, overlap, and reintegrate. In this sense, what we describe as reality is built from continuous reconfiguration. The underlying structure remains, while its expressions change. This is not a final description of reality. It is a working model, one that sought coherence at the level of the essence of everything, leading to gravity as the foundation of reality itself.